The other day, we covered Section 4.1. And we had a long list of rules for exponents. There were all of our rules. Let's review these quickly. The first rule was the basic one that we knew. If we have something to a power, it means multiply by itself over and over again. And then we did some examples, and we saw the second rule made sense, that if the bases are the same and we're multiplying, we add our exponents together. And then in a similar way, we saw that if we're dividing, it made sense that we should subtract our exponents. And then once we had that division rule, that led to a couple new rules. Led to rule number 4, where b to the 0 should be the number 1, except when b is not 0. And negative exponents made fractions. Or, number 6, conversely, if you have a negative exponent, and the negative exponent is already in the bottom, then what happens to that negative exponent? It goes to the top. And then finally, we had a couple distributive properties. If you have two things multiplied together and you have a power, you distribute the power goes to both of them. Same distributive property works for division. If you have division, a fraction all raised to a power, you distribute, the power goes to both of them. And the last rule we had is if you have a power followed by another power, then you multiply the powers. So those were all of our rules. Section 4.2, we have one more rule. So, find a clean piece of paper here. Section 4.2 is about rational exponents. What does the word rational mean? Rational looks like ratio, R-A-T-I-O. What does ratio mean? What's a ratio? What's that? It could be a 1-to-1 ratio. It could be 1-to-2. It could be, so a 1-to-2 ratio is sometimes written this way. How else do we sometimes write a 1-to-2 ratio? Sometimes written as a fraction, 1/2. So what's a ratio? A ratio can be written as a fraction. So what's rational mean in math? It means fraction. So we're looking at exponents that are going to be fractions. That's the one thing we didn't have in our previous section. In our previous section, all of our exponents were nice integer numbers. Today we're going to talk about what happens if your exponents are fractions. So let's say I gave you something like 4 to the 1/2. So I have a base, 4, and I have an exponent. My exponent is 1/2. And then I'm going to ask you, what would happen if I were to take 4 to the 1/2 and I chose to square it? What happens when I have a power followed by another power? You multiply those powers. What's 1/2 times 2? It's 1. So this is 4 to the 1, which is a fancy way of writing 4. So 4 to the 1/2, I'm not sure what that is, but I know if I take 4 to the 1/2 and I square it, I get the number 4. Do I know another number that when I square it, I get the answer 4? I know if I take 2 squared, I'm also going to get the number 4. So that leads me to believe that 4 to the 1/2 should be what? 4 to the 1/2 should be the number 2. Because when I take 4 to the 1/2 and square it, I get 4. When I take 2 and square it, I also get 4. So it seems reasonable that 4 to the 1/2 should be the number 2. They are exactly equal. 4 to the 1/2 is exactly equal to 2. All right, how about if I were to take, let's see, I need another nice number. How about 25 to the 1/2? I'm going to do the exact same trick. I'm going to take 25 to the 1/2, and I'm going to square it. If I take 25 to the 1/2 and I square it, what do I get? 25 to what power? The first, which is a fancy way of just writing 25. Do I know a nice regular old number that when I square it, I happen to get the answer 25? A nice regular number that I know is 5. 5 squared gives 25. So once again, I'm inclined to believe that 25 to the 1/2 should be what number? 5. All right, so how are these things related? Well, it's not dividing. If I take 25 and divide it by 2, I'm certainly not going to get 5, am I? 25 divided by 2 would give me 25 and a half. 25 halves, whatever that is. It looks like it works this for the number 4. It looks that way. 4 divided by 2 happens to give 2. 4 probably wasn't a good number to start with. What else happens? How are 25 and 5 related? They do have common factors, that's true. I heard somebody say something about square roots. What's the square root of 25? 5. What's the square root of 4? 2. So what are these fractional powers doing? They're giving square roots. All right, so if I write 81 to the 1/2, that's nothing more than a fancy way of writing square root of 81. And square root of 81 is a nice number. Square root of 81 happens to be 9. Okay. What if I didn't use a 1/2 power? What if I used a 1/3 power? What if I said 64 to the 1/3? What's that? You put the 3 on the outside of the radical symbol, and it's not called a square root anymore. It's called a cube root or a third root. So this is a fancy way of writing cube root of 64. So, just as we saw negative powers gave fractions, fraction powers give what? Fraction powers give roots. They might be square roots, they might be cube roots, they might be fourth roots. What's the cube root of 64? 4 happens to be 4. Alright, so I would imagine that you know a lot of square root numbers, but you might not know cube roots so well. How do you do cube roots in your calculator? Alright, there's 2 ways to do it. You can go under Math, and there happens to be a cube root symbol right there. So I could go cube root 64. And again, my calculator has the newer operating system. With the newer operating system, it draws the little cube root sign, like so. If you have an older calculator, it doesn't. It puts a little cube root and then puts a parenthesis. Same thing happens. Cube root of 64 is 4. The other thing I could do is I could write 64 raised to the 1/3. And again, if you have the older operating system, you're going to need to put that 1/3 in parentheses. On the newer operating system, it moves the whole thing up as an exponent and it works out. That would be 4 still.
You don't divide it?
Yeah, well, let me switch to the old operating system to show you the difference. On the old operating system, I go 64, then I put a caret, then I would have to put a parenthesis, 1 divided by 3. So you use the division symbol, just use the division button on your calculator to get the fraction. So under the old operating system, it would look like that. All right, how about if I give you a fourth root or a fifth root? What if I asked you for the fourth root of 81? How would you do fourth root on your calculator? You go to math, and it's number 5. That's true. But if you want to do fourth root, what you need to do first is you actually need to type in the 4 first. So to do fourth root, you type the number 4, then you go math, then you go down to that one. And what that does, notice it puts a little X up here. What it's going to do is it's going to take the number 4 and plug it in for that X up there. And then you would type 81. Fourth root of 81 happens to be a nice number. It's 3. Your other option would be fourth root of 81. How could I write fourth root of 81 as a power? 81 to the 1/4. So I could take my calculator and I could go 81 raised to the 1/4. And again, with the old operating system, you've got to put that 1/4 in parentheses. My calculator will give me the same answer, 3. Questions on that? All right, how about if I gave you something like this? 4 to the 3/2. What if I gave you a fractional power, but I didn't just give you a 1 on top? What if I gave you a 3 on top? Any ideas what you do with that? Okay, I could just plug it all into my calculator. That's true. Calculator tells me 4 to the 3/2 happens to be the number 8. Oops, you can't see it. There it is. Number 8. How did my calculator arrive at that answer, though? Don't know. Close. All right, I'm going to rewrite this. I'm going to rewrite this as 4 to the 1/2 cubed. Why are those the same thing? What happens when you have a power followed by another power? What do you do with the powers? Multiply them. What's 1/2 times 3? 3/2. So that's the same thing. So this 4 to the 1/2, what's the 1/2 power do? That's a square root. So that's the square root of 4, and then I have to cube it. So notice what happened. This number on bottom became the root. And what happened to the number on top? The number on top is the exponent. Square root of 4 is 2. 2 cubed happens to be 8. So the good news is the calculator gave us the right answer. The right answer should be 8. All right, so one more of those. How about, I need a good number. 8 to the 5/3. So this time you notice that your fraction has a 3 on bottom. If you have a 3 on bottom, what root is that? Cube root. So this is going to be the cube root of 8. And then whatever answer that is, I need to do a 5th power. What's the cube root of 8? 2, because 2 times 2 times 2 gives me 8. So this is 2 to the 5th. 2 to the 5th happens to be 32, I think. Questions on that?
I have a question. Do you have to put in parentheses? Because you're writing it like that. Do you have to write?
No, I suppose not. I suppose cube root of 8 to the 5th would be okay.
Okay, I just wasn't
a habit that I have of putting them in parentheses. But I don't think you need it. I think it would be all right. Well, your calculators, if I were doing this problem, I probably would have just left it as a fraction. I probably would have just done 8 to the 5/3. If I'm using my calculator, I probably don't change things to roots. I leave them just as powers. I think it's easier to type it in. 32. All right, now I got a trick question for you. What's negative 9 to the 1/2? Positive 9? Nope.
You can't have a negative in the square root.
It would be the square root of negative 9. And you're telling me I can't do that. Why not?
Just can't.
You do end up with something called imaginary numbers. That's correct. We will talk about imaginary numbers later in this class. But the real problem is, for example, if I were to take 3, sometimes people will tell me the answer is 3, but 3 times 3 gives me 9, which is not negative 9. Other people will try to tell me the answer should be negative 3. But what's negative 3 times negative 3? Also 9. So is there any number that I can take, multiply it by itself, and get an answer of negative 9? No. So at this point, we say our answer is no real number. So you need to be careful. You cannot have negative numbers under square roots. Can I have negative numbers under cube roots? I can? How come I can have negative numbers under cube roots? A negative times a negative times a negative will give me a negative. So what's the cube root of negative 8? Negative 2, because negative 2 times negative 2 is 4. 4 times negative 2, it will work. It can be negative 8. So, I can have negative numbers under cube roots, but I cannot have negative numbers when I have square roots. Can I have negative numbers when I have 4th roots? No. Can I have negative numbers when I have 5th roots? Yes. So what's the rule on that? When you have odd roots, it's okay to have negative values. If you have even roots, is it okay to have negative values? No. Alright, so I'm going to skip down here to number 2. Number 2 says, take 27b to the 27 and raise it all to the 1/3. Alright, so how would I take 27b to the 27 and raise the whole thing to the 1/3? Distribute, right? I have more than one thing inside my parentheses and an exponent on the outside, so I distribute. So I'm going to have 27 to the 1/3, b to the, what would the power on b be? B to the 9th. Why b to the 9th? You multiply your powers. It doesn't matter that one of the powers is a fraction. When you have a power followed by another power, you multiply your powers. 27 times 1/3 is 9. Almost done. One more step. Well, how much is 27 to the 1/3? I don't think it's 9. I think it's 3. Because it's the cube root of 27. The cube root of 27 happens to be 3. 3 times 3 gives 9. 9 times 3 is 27. So I would write my final answer as 3b to the 9. Alright, how about B? B has 6bc squared all to the 5/7 times 6bc squared all to the 2/7. Alright, so you're going to have lots and lots of fractions in this section. Nope, it's 6b c squared. Yep. 6b c squared, all raised to the 5/7. And then it's 6b c squared again, same thing over again, raised to the 2/7. All right, so I'm going to have 6 to the 5/7. B to what power? 5/7, because you multiply your powers. 5/7, the power here is a 1. 5/7 times 1 is 5/7. C to the what power? 10/7. You take 5/7, you multiply by 2. Think of 2 as 2 over 1. You multiply tops, multiply bottoms. C to the 10/7. Not very nice so far. Let's keep going, see what happens. Distribute the 2/7 through. I'm going to have 6 to the 2/7. B to the 2/7. C to the 4/7. Alright, looks gruesome. Looks even worse when you can see the whole thing. It's about to get a lot better though. Combine the 6's. What's 6 to the 5/7 times 6 to the 2/7? 6 to the 1. Why does that become 6 to the 1? What do you do with those powers? You're multiplying, so you add them. 5/7 plus 2/7 makes 7/7, which is a fancy way of writing 1. So that becomes 6. Same thing happens with the B's, doesn't it? You have a 5/7, you have a 2/7. You add those together, that's 7/7. So you have B to the 1. Then how about the C's? C squared, because 10/7 and 4/7 makes 14/7. 14/7 is a fancy way of writing 2. So that one started ugly with a whole bunch of fractions, but it turned out it worked out pretty nicely, ended with nice numbers. Yes?
Would you multiply the 6's together?
No. Why not? So his question is, if I have 6 to the 5/7 times 6 to the 2/7, he wants to write it as maybe 36 to the 7/7. That was one of the rules, that's correct. When the bases are the same, we have a 6 here and we have a 6 here, the 6 doesn't change. What's the only thing that changes? The powers. You add the powers. Okay? So that would be incorrect. You wouldn't want to do that.
So you said the B.
9 to the 3/2. What'd you do? The 2 on bottom tells you you have a square root. So that's square root of 9. And then you're going to cube it. What's the square root of 9? 3. And then 3 cubed is 27. B, we have 27 to the negative 2/3. Let's deal with that minus sign first. What's that minus sign going to do? What do negative exponents do? They make fractions. So it's going to take whatever our answer is and it's going to put it in the bottom. So I'm just going to get rid of that negative sign first. I'm going to write this as 1 over 27 to the 2/3. The negative exponent simply takes our thing, drops it to the bottom. Negative exponents switch top and bottom. And then we get the same process. We have a 3 on bottom. A 3 on bottom tells us that we have a cube root. So this is 1 over, I've got a cube root of 27. And then what's that 2 on top tell me to do? Square it. Cube root of 27 happens to be 3, and 3 squared is 9. So the answer should be 1/9.
Is that the one we can do on our calculator with the effect the number and
Absolutely. You could go 27 caret negative 2/3. The calculator will give you that, but that's not a very nice answer, so we go math, enter, it'll tell us 1/9. Of course, the directions were to do it without using your calculator, so that would be kind of not following directions. But there was nothing preventing you from checking your answers using your calculators, of course. C. C should be the easy one. C is no real numbers because this is square root of negative 16. No real number. All right, now let's jump down to B. C, B to the negative 2/3 divided by B to the 1/7. This one seemed to be causing a lot of problems as I was walking around. What do you do? You're going to need a common denominator eventually, yes. Okay, you've got two choices. Choice number 1, take the negative power, drop it down to the bottom. Choice number 2, you're dividing, so when you're dividing, what do you do to your powers? Subtract them. I think that's what I would do. So this is the same as B to the negative 2/3 minus 1/7. You simply subtract your powers. So the hard part of this problem is you got to take negative 2/3 and subtract 1/7. How do you take negative 2/3 and subtract 1/7? You don't get a common denominator, you get your calculator. Negative 2/3 minus 1/7. You're going to have lots of fractions in these problems in section 4.2. Your calculator is your best friend because your calculator will handle all these fractions for you. Look at that ugly number. I don't know what that is. What my calculator does, it says it's negative 17 over 21. So that's B to the negative 17 over 21. But I'm not allowed to write my final answer that way. What would I do for my final answer? I got to drop that to the bottom. The directions say I have to write my answer with positive exponents. So I drop that to the bottom. 1 over B to the 17 over 21.
Because you can't use y.
Because the directions say writing your answers with only positive exponents. The directions told me I was not allowed to leave my answer with a negative 17 over 21. Fussy directions. So I followed them. All right, the last one. I think what I would do with the last one, there's lots of ways to do it. I think what I would do is I would kind of follow the order of operations. And the order of operations tells me I should clean up what's inside my parentheses first. So I think that's where I would start. Although other people would say, take that 4/3 and distribute it through. And truthfully, that would work. Right? I personally think it's easier to clean up inside. Okay, so I have 27 over 8. Can I reduce 27 over 8? Anything common? Anything cancel out? No. So I'm going to have 27 over 8 still. Okay, how about the b's? I've got a b to the 1/3 on top and a b to the negative 2/3 on bottom. I bring the 2/3 to the top. So that's going to give me a b to the 1/3 and a b to the 2/3. Both on top. What am I going to do with those powers? I'm going to add them. And I'm going to get a b to the 1. So that's just b to the 1 up on top. The way I thought of it was I would subtract my powers. 1/3 minus negative 2/3 is 1/3 plus 2/3, which is 1. So that's kind of nice. That made some of those fractions go away. How about the c's? I have a c to the 3/4 on top and a c to the 1/2 on bottom. What do?
You subtract.
I subtract my powers. Okay, again, I'm going to use my calculator. 3/4 minus 1/2. My calculator tells me the answer is 1/4. So that's going to be c to the 1/4.
I mean, you could have, the way I'm looking at it is that, I mean, you could have done like, it without the calculator.
Oh, I could do it without the calculator. I would have to write it as 3/4 minus 2/4, because in order to subtract fractions, I got to have a common denominator. So 2/4 minus, or 3/4 minus 2/4 does give me 1/4. So yes, you could do it without a calculator. My suggestion is in these problems, to do all the arithmetic on the fractions, use your calculator. That's really my suggestion. All right, now we have to take this power and distribute it through. So I'm going to have 27 to the 4/3, b to the 4/3, c to the, I got to distribute my power. I have a 1/4 and a 4/3. What do I do when I have a power and another power? Nope. I multiply them. What's 1/4 times 4/3? 1/3 over 8 to the 4/3. And the last thing I would do on this problem, I would ask myself, is 27 to the 4/3 a nice number, or is it some big long decimal? Turns out 27 to the 4/3 is a very nice number. Turns out to be 81. Again, you could use your calculator. B to the 4/3, C to the 1/3. And then the same thing is 8 to the 4/3 a nice number. It happens to be 16. If it's a nice number, write the nice number. If it's a big long decimal, what are you going to do with it? Leave it as 8 to the 4/3.